So let's go ahead and finish up optimization. So this next one here says, find the point on the graph y equals the square root of x closest to the point 4, 0. So closest, that's our maximum, or really in this case our minimum. Now we're trying to maximize, or in this case minimize, the distance between a curve and a point. So that should tell you, when I say we're trying to minimize the distance, that we need the distance formula. So that is square root x2 minus x1 squared plus y2 minus y1 squared. Now we've got a point right here, and I'm going to call this point x1, y1. We just need the other point. Well, that would come from the function. So if x2 is equal to some x, then y2 is equal to the square root of that x. So our point then is x square root x. So then we just need to plug that in with our original point up there. So this becomes square root. We've got, this is our x2, so it's x minus 4 quantity squared plus, down here we have square root x for the y2 minus 0 squared. And that turns out to be really nice because I end up with the square root of x squared so I get that. And then if you really want, we can multiply this out. So this is going to be x squared minus 8x plus 16 plus an x, and that's going to be x squared minus 7x plus 16. Well, that's the distance between that function and that point, but we want to minimize that distance, so we have to take the derivative of this guy. Now, what I would like to tell you is that effectively it's the same to maximize or minimize the distance as it is to optimize the distance squared. So actually, I think I'm going to go back to this form, and I'm going to square the whole thing. So distance squared is just going to get rid of the square root. And then instead of little d squared, I'm going to call it let's call it big D. So minimize big D instead of D. Let's just say that instead of D. And the reason for that is there's no difference in if we minimize one or the other. We're still going to get the same value. It's just easier to do it such that we don't have the square root. If we leave the square root, we've got to take and use chain rule on the square root. So again, if you wanted, you could take that form there as well. I'm going to take the derivative of d with respect to x. So that's going to give me 2 times x minus 4 to the first times 1 for the derivative of x on the inside. And then derivative of x is plus 1. And I'm going to set that to 0. Now remember, I'm trying to find the point on the graph. So whatever I get out of this is going to give me an x value. I'm going to then need to plug it into that equation to get the y value. So then, solving this, I have x minus 4 equals minus 1/2. X equals 4 minus 1/2. So that's what, 7/2. So there's a question. Why does y2 equal the square root of x? So we're asked to find a point on this line, or this curve, that's closest to this point. So if I want to figure out any point on this curve, it would have some x value, and then the y value would equal the square root of x. So that just represents any point along that curve. So we got x equals 7/2. We then need to plug it back in there to get y. So the point would be 7/2 square root 7/2. So according to this calculation, this point, which lies on this curve, is closest to this point. So again, if you like, you could plot this curve and that point on a graph and look and see if they look like they're the closest. You could do it on graph paper and measure the distances if you are unsure. Any other questions about that one, guys? I have another one here that's very similar to that one. So how about I just go ahead and do that one and then see if there's any questions. Alright, so this says, find the point on this line now that is closest to this point. So first off, let's solve that for y. Y equals 9 minus 6x, or if you prefer, minus 6x plus 9. So any point on this curve would be represented by x and then 9 minus 6x, right, because that's y. So again, we are trying to minimize the distance between that point and this point. So again, the distance formula is square root And it's up to you which one you put first. So I'm going to go ahead and put that point first, I guess. So this would be x minus a negative 3, or x plus 3. And then this side would be 9 minus 6x, all minus 1. Right, because this is x2 minus x1, and this is y2 minus y1. So again, I'm going to go ahead and square both sides. And by doing that, I get rid of the radical. So I've now got x plus 3 squared, and this one is 8 minus 6x squared. Again, you could multiply this all out. I'm going to go ahead and use chain rule on both, because we really should be able to, or we should have a really good handle on that by now. So the derivative of big D with respect to x, I'm going to bring this 2 down, leave the inside, and the derivative of the inside is just 1. And then on this one, bring the 2 down, leave the inside, and the derivative of the inside is minus 6. And then the last thing is, in order to maximize or minimize, this has to be equal to 0. So we now need to solve that. So first thing I notice is everything's got a 2 in front of it. So if I were to divide everything by 2, right, that would just go away. Right, so we've got x plus 3 minus 48 plus 36x. So it looks like 37x. And this minus 3 would be 45. Move to the other side. So not a very pleasing value to end up with. So that would be x, and then we have to get y as well, so that would be 9 minus 6 times this value. So if that comes out as anything nice. I don't think that it will, because we got 37, not 36 there. That's 270 over 37, and then 9 minus that. So at the end, it looks like our point is 45 over 37 and 63 over 37. So again, not a nice round pretty number, but not too terrible. So any questions about that? Alright, so I don't see any questions, so I'm going to go ahead and erase this guy and continue. Right, the main thing for optimization is just, the hard part is, can you find the equations that are required? And once you have them, it's just a matter of taking the derivative and setting it to 0. Alright, so this says a farmer has 200 feet of fencing, and that should say wishes. Oops. Come on. Wishes, there we go. Okay. To create 2 adjacent rectangular corrals. Just means 2 fenced-in areas. What dimensions should be used to maximize the area? Okay. So 200 feet of fencing. We know he wants 2 adjacent, right, so touching, rectangular fenced-in areas or corrals. And it says what dimensions should be used. Well, that 200 feet of fencing, what do you guys think that is giving me? What quantity? All right, I'll give you some options. Do you think it's the area or the perimeter? All right, there's one answer. Anybody else want to chime in? So I guess everybody else is away from their computer, so I'll just go ahead and... Oh, there we go. There's another answer. So yeah, that is the perimeter. That's 200 feet. And so I have to define these values here on the lengths. So I'm going to call this length X and this length Y. So that means this is Y, this is Y, this is Y, and then there's X, 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 and X. So my total perimeter is equal to 4X plus 3Y. Now, we want to maximize the area. So I need an area equation. So area is equal to, that's going to be this length, which is 2X times that length, which is Y. So we've got two equations, and if this is perimeter, this has to equal 200. So this is my primary and this is my secondary equations. Right, the secondary has the data given, and the primary is the one that you're trying to maximize or minimize or optimize. So I need to solve this one for X or Y, plug it into this one. So I think I'm going to solve for Y here. Oops. Okay. So Y equals, I would just move the 4X to the other side. So that would be 200 minus 4X. And then to get Y by itself, divide by 3. Now I'm going to plug that in to my area equation. So then I want to, I guess let's multiply that in. So that would be 400x minus 8x squared all over 3. And I want to take the derivative of that. So dA dx, and I need to set it to 0. So that 1/3 there doesn't really matter, right? So I really just need to take the derivative of the top here. That would be 400 minus 16x. So get rid of the 1/3 by multiplying both sides of the equation by 3. And then over here it's just still 0. So we have 0 equals 400 minus 16x. So y set it to 0. So every time you do an optimization problem, you have to differentiate and set to 0. Remember that the critical values occur at points where the slope is 0. Our derivative represents the slope. And so where the slope is 0, that's where your curves have this kind of behavior, right? So either there or there, which are maximums or minimums. So, all right, that was a good question. So I'm going to move the 16x over. 5/16. And what does that make x? So that's going to be 25. Check myself on that math. Hey, my brain's working this morning, guys. 25 it is. So that's the value of x. We also need to find y. So we would need to take this guy, plug him back in there. So then we've got 200 is equal to 4 times 25 plus 3y. Well, 4 times 25, that's 100. And if I move it to the other side, that would be minus 100 over there. So we get y equals 100 thirds, or if you prefer, 33.333 repeating. I always like to have whole numbers. So then the last part is, right, it says what are the dimensions? Well, x is half of one of these sides here. So I really need for the dimensions to be y and 2x. So one side is 100 thirds, the other side is 50. Another thing that could be asked is what is the total area? If it asked you that, well, that's simple. That's just 2x times y. So that's just 5,000 thirds. So given 200 feet of fencing and requiring that you cut it into 2 rectangular adjacent fenced-in areas, your total area that you would get if you maximize that amount of area is 5,000 thirds. So how are you guys feeling about these so far? How did we get 2x equal 50? I just took so x is 25, and I want to know the total length of this whole side, so that's 2x. So I just did 2 times 25. Yep, no problem. So again, half the hard or the hard part about these is really, oops. So yeah, the derivatives so far haven't been so bad, but the hard part is really just getting the equations out of the word problems. Am I okay to erase this, guys? Don't forget, you can take screenshots, and the videos will be posted on YouTube as well. So I'm not seeing any responses again, so I'm going to go ahead. All right, thank you. Right. So this one's asking us to find the dimensions of a rectangle that has a particular area and whose perimeter is as small as possible. So rectangle means we have one side X, one side Y. Tells us the area at the beginning. The area is equal to length times width, or X times Y, and that's got to equal 1,000. Then it asks us to minimize the perimeter. So perimeter is going to be 2x and 2y added together. So again, I need to take this one here is my primary. This is my secondary. I need to solve this one for one of the variables, plug into this one, take the derivative, set it to 0, and solve. So this first one, I'm going to solve for x this time. So this is x equals 1,000 over y. I'm going to take that and plug it in right here. And so now perimeter is 2,000 over y plus 2y. I need to differentiate that perimeter. So I need dp dx, or sorry, in this case dy. So the 2y is easy, right? That's just 2. And then what about the 2,000 over y? So remember, that's really y to the minus 1. So I would bring a negative 1 down in front and then divide by y squared, right? Because the power has to, you have to take 1 away from the power. It's already negative 1. Let me just write it up here. So we're effectively taking the derivative y to the minus 1. That's minus 1y to the minus 2. Or minus 1 over y squared. So you said I lost you, but did I catch you back up with doing this guy? Okay. So I have 2,000 over y. That 2,000, if I differentiate, is just going to go along for the ride, right? So 1 over y is the same thing as writing y to the negative 1. We okay with that? Okay. So then when I differentiate this, you bring that power down in front, right? Minus 1. and then subtract 1 from the power that it had. So -1 minus another 1 is -2. And then the -2 says, you know what, I'd prefer to be in the denominator and positive. And the only difference between this and that is that I have a 2,000, so I just multiply by 2,000. And again, I'm trying to minimize, so equal to 0. I'm going to move this term to the other side to make it plus. So 2 equals 2,000 over y squared. And as I've been showing you guys, right, without doing 2 steps, we can just do 1 here. We can swap these 2 guys. So y squared equals 2,000 divided by 2, or y equals the square root of 1,000. Now technically, you would get plus and minus here. Hopefully it's clear to you that you can't have a negative length. So only the positive square root of 1,000 is a solution. So that's sort of where that, the part where it says to create a feasible domain steps in. And so the best we can do with that is make it 10 square root 10. Why did you swap out the 2 and y squared? So I'm trying to get y by itself, and so if you really wanted, you could come back here and you could do times y squared, and that would give me 2y squared equals 2,000, and then you'd have to divide by 2, right? Which would give you y squared equals 1,000. So instead of doing those 2 steps, right, I've done this so many times that I've realized that if I have a fraction equal to a quantity, you could flip those 2 values. Some of the students like to call that algebra tricks. I just like to call it algebra. So y is 10 root 10. If we want to find x, then we need to plug it back into this equation, or even here's better, because it's already solved for x. So that's 1,000 divided by 10 root 10. That would be 100 over square root of 10, or 100 times square root 10 over 10, which turns out to be 10 root 10. So the interesting thing in this problem is that they told us we were creating a rectangle, right? X and Y. They had to be different lengths. But it turned out that both X and Y are the same length. So if you want to minimize a rectangle, it turns out to be a square. So I always thought that problem was kind of fun. Any other questions about that guy? Alright, so let's go ahead and I think this rectangle inscribed in a circle is the last one. And I can also tell you currently that you can expect one of these on your exam. I was recently talking to one of the other math professors, and I was trying to say that I think optimization is what I call the culmination of Calc 1. Right, there's still stuff to be done, but that's really the you get the most out of Calc 1, right? How to take derivatives, what's the point of a derivative when finding the optimization. All right. So a rectangle is to be inscribed into a circle with radius 5. What are the dimensions and what is the area of the largest such rectangle? So what do they mean inscribed? Well, they really just mean we've got a circle, and inside of said circle is some kind of rectangle, and it has to touch all sides of the circle, or all four corners of the rectangle has to touch the circle. Probably the best way to say it. Alright, so forgive me for my terrible circle, but there it is. So this one is really tough, right? We need to know the dimensions of this rectangle, but we're given absolutely no equations, right? We're just given the radius. Well, the interesting thing about the radius of a circle is that if I draw it from the center to any point on the edge, that's my radius. So that's a radius. This down here is a radius. What if I drew it from this corner up to that corner? What would that be equal to? So I'm anxiously waiting over here to see what your guys' responses are. So recall the radius is from the center out to the side. So what is that length that I just created? Right, the diameter, or 2 times the radius. So yeah, it would be 10. So this is 2r, And then I can use Pythagorean theorem, right? And I can call this x, and I can call this y, and that'll then help me find the dimensions of my rectangle. So x squared plus y squared has to equal 2r squared. Or in this case, because r is 5, this is 10 squared, or 100. All right. And they say, what is the area of the largest rectangle? So I need my area of the rectangle, which is x times y, and that is the thing that I am trying to maximize. So I need to take this equation and solve for one of these two. Let's do y, I guess. So y equals 100 minus x squared square rooted. And of course you would get plus and minus here, but I need y to be a positive value, so I have to use the positive portion. And I'm going to take this, plug it in here for y. So I have that. And now that I've got all the hard work taken care of, then I need to take a derivative and set it to 0. So let me rewrite this as x times 100 minus x squared to the 1/2. We need to treat this as though it is a product. So derivative of x is 1. Leave this alone. Plus, leave the x alone. Derivative of this to the 1/2 power, you bring a 1/2 down. So we know there's a 2 here. This becomes to the minus 1/2, or in the denominator, to the positive 1/2. And then we need the derivative of the inside, which is minus 2x. So let me go ahead and just redo that derivative quickly. So the derivative of 100 minus x squared to the 1/2. Bring the 1/2 down in front. Leave the inside alone. The derivative then takes 1/2 minus 1, which is minus 1/2. And then the derivative of the inside is minus 2x. So if you simplify that, the 2's cancel. You have minus x on top. And this minus 1/2 power says put that in the denominator. So I've done the same thing down here. I just didn't simplify my 2's. So let me come back over here because I think it's a little clearer. I currently have 0 equals 100 minus 2, or sorry, x squared to the 1/2. And then I have minus x squared over 100 minus x squared to the 1/2. So I'm going to do quite a bit of algebra here, so please ask questions in the chat if you have them. This is negative, so I'm going to move this whole term to the right or to the left. Now the nice thing here is that I've got a quantity in the denominator on this side that is the same as this one, and they're both to the 1/2 power. So if I were to take this to this side by multiplying it over there, something to the 1/2 times itself to the 1/2 becomes that something. So this is x squared equals 100 minus x squared. Right, I basically just did square root of 2 times square root of 2 gives me 2. That's the same idea as what I just used. You could then move this x squared back to the other side and add it. And then it should be pretty clear to you that you divide by 2 and take the square root. So that is 5 square roots of 2. For x. I'm going to pause here for a second. I'm assuming there are questions. Please ask them. Alright, so I don't see any questions, so I'm going to assume you guys are all okay. So I've got x, I need to find y. My equation for y is right here. So I just need to plug this back in for x, or even that form. So this will be the square root of 100 minus the square root of 50 squared, which is 50. I get back square root 50, or 5 root 2 for y as well. So yet again, we were fooled, right? They told us it was a rectangle. And it turns out that, in fact, it's a square. And that should make sense to you, right? If I have a circle and I try to put the largest possible parallelogram inside of it, then that should be a square. So the dimensions are 5 root 2 by 5 root 2. And it says, what is the area? Well, that's x times y. So that's 5 root 2 times 5 root 2, which is 25 times 2, or 50. So length 5 root 2, width 5 root 2, and area of 50. All right, so as I said, there's two light sources. Let's call them light bulbs. And they tell us that the luminance, which is basically just its brightness, and as I was saying, a light bulb, you would, if you look at any kind of flashlight, they tell you how many lumens. That's basically how bright it is. So E is luminance, and it's equal to this quantity F, which is going to be intensity. Why they used F here, I have no idea. Over 4 pi d squared. So why 4 pi d squared? Well, that's the surface area of a sphere, and if you know, the light from a light bulb is going to come out in a spherical wavefront. It says that you've got two light bulbs that are 3 meters apart. So again, forgive my light bulbs. Okay, there's our light bulbs. They're 3 meters apart. With respective light intensities of 1700 lumens and 1000 lumens. So this is F1, F2. Where between these light bulbs will the sum of their luminance levels be a minimum? So basically, where is the darkest position between the two light bulbs? Well, we know it's somewhere between them, but we don't have a clue where. And I would normally give this to you guys to try, because it takes a little bit of thinking. But because we have no idea where to put it, let's just pick a position. Let's assume right here is going to be the dark spot. And I'm going to call the distance between this light bulb and that spot X, which means the distance between that point and this bulb has to be the total of 3 meters minus X. And we need that because we've got this distance d here. So when we solve, we're going to solve for x, which just means we're getting the distance from this bulb to the dark spot. And the nice thing about luminance is it just adds up. So the luminance of this bulb at that point plus the luminance of that bulb at that point will give us the total at that point. So E total is equal to, we've got 1700 for that bulb over 4 pi, and the distance is x. Then the second part would be plus 1000 over 4 pi, and the distance for this one is 3 minus x quantity squared. Are you guys completely lost because you don't understand the topic? Or are we okay so far? So as you guys are answering that, I'm going to go ahead and continue. All right. So this is the equation for the total brightness at this point. We want to minimize this brightness, right? We're trying to find the lowest brightness. So to do that, I have to take a derivative, and I have to set it to 0. So, derivative of this first piece, right? I'm finding dE dx. Well, that's 1700 over 4 pi, derivative of x to the second in the denominator. Again, that is d dx of x to the minus 2. Derivative of this is minus 2x to the minus 3, or minus 2 over x cubed. So same thing here. We're going to get minus 2 over x cubed. Plus, now we need to differentiate this piece. And before that, we could even simplify this slightly, right? Because 1000 over 4, that's 250. Then I need to differentiate 1 over 3 minus x squared. Again, I would get 2 times this quantity, but to the minus 3. And I have to set this whole thing equal to 0. So the reason I didn't multiply that negative 2 in is, well, I've just set it to 0. So if I divided every single term by negative 2, that'll disappear. And same thing with the pi, right? If I were to multiply through by pi everywhere, the pi would disappear. And I always love this problem because I've given it to students in the past and they've gone to friends, parents, coworkers, and asked to get help with it, and some people have told me that this problem is not solvable, but that's not the case. Where did I get 250 from? I simplified. Yeah, I had the 1,000 over 4 here, and I just changed it to 250. All right, so I've got two things now equal to 0. I did forget one thing, because I'm looking at this and I'm noticing that everything's positive, which is going to cause some trouble here possibly. And I did forget one part of this derivative. So you would get -2 times this quantity to the -3, which I have here, but I forgot times the derivative of the inside, which is -1. Alright, so now I'm just going to move this to the other side. And now I'm going to do some mathemagic to solve this as quickly as possible. So I've got two fractions equal to one another. That means I can flip both of them, and they still are equivalent. I'm then going to take this 4x cubed. I think I'm going to move it over here and move the 250 over there. So I'm going to multiply by 250, divide by 4x cubed. And the reason I do that is I'd have 3 minus x cubed. Actually, I'm going to leave the 4 over here, sorry. If I leave the 4 over here, 250 times 4 is back to 1,000. And I'm just going to divide by the x cubed. Just check what you got. Okay, no new questions. Now the reason I do that is I've got this quantity cubed over x cubed, which means I can write it as both quantities cubed. Now if I do that, I can take the cubed root of both sides. So I have 3 minus x over x equals cubed root of 1,000 over 1,700. And here's where people try to tell me that you can't solve it. I think the easiest way at this point is probably to divide these into separate fractions. So this is 3 over x minus 1 equals the cubed root of this number. Let's go ahead and get rid of these zeros here. Add 1 to the other side. And again, as I've done this trick many times now, I'm going to take all of this and switch it with that x down there. So after all that's done, it's not a pretty number, but it is a solution. We get x. So my guess is, if I lost you at some point, it was either this derivative or that algebra. If you have any trouble repeating this problem on your own, then set up a video conference with me or shoot me an email. Anybody have any particular questions now? All right, anybody other than Naya have anything to say? Or Shelby? If it makes you feel better, you've already earned your 1.5%. Alright, so if there's no other questions, I'm going to go ahead and stop the recording. I'll put that up. I'll look and see if I have a quiz for you. And like I said, if you guys have any questions outside of class time, feel free to ask. I'm here to help. Right, it doesn't do much good for me to sit here and talk to myself. So, hope to hear from you guys. If I do not, have a good rest of your day.